Okay, here we're going to talk about how to determine the equation of an altitude in a triangle, as well as how to determine the length of an altitude in a triangle. So here we have triangle with vertices D, E, and F, as shown on the graph. So we can connect those three vertices to make our triangle. And when we're talking about the altitude from vertex E, the altitude will go from vertex E and will connect to the opposite side at a 90-degree angle. So not necessarily at the midpoint, like a median would connect from vertex E to the midpoint. We want to make sure that we're connecting vertex E to side DF at a 90-degree angle. That's the important part of an altitude. So an altitude of a triangle connects one vertex of a triangle to the opposite side at a 90-degree angle. So here we know that the slope of the altitude is very important. The slope of the altitude must be perpendicular, or it must be a negative reciprocal to the slope of df. So let's start this question by calculating the slope of df. So here we take the coordinates of points D and F. We're going to subtract the y coordinates. So we get 2 minus -1 divided by, we subtract the x coordinates, 6 subtract -3. And here we get 3 over 9, or simplifying to 1/3. So if the slope of df is 1/3, then we know that the slope of the altitude is the negative reciprocal of 1/3. So the slope of the altitude will be -3. So now if we're determining the equation of that altitude, we know that the slope is equal to -3, and we know that the altitude goes through the point E. And that's the only point that we know for sure that the altitude goes through. We don't know the coordinates of this point here, where the altitude connects to the line DF, but we do know that the altitude will go through vertex E for sure. So vertex E has coordinates of 2, 4. So we know the altitude goes through 2, 4. So the equation of this altitude is in the form y equals -3x plus b. And we can substitute the point 2, 4 for x and y. So we have 4 is equal to -3 times 2 plus b, which means 4 is equal to -6 plus b. Adding 6 to both sides, we get that b is 10. And so we know that the equation of this altitude is y equals -3x plus 10. Okay, next we're going to determine the length of the altitude from vertex E. So again, I'm going to draw in our triangle here. And we've still got the altitude connecting vertex E to the opposite side at a 90-degree angle. But here we want to find the length of this point from E to, let's call this point here, G. So we want the length from E to G. So we do know that the vertex E is at 2, 4, but we don't know what the coordinates of point G are. Right? We could do some guessing based off the graph, but chances are we haven't drawn in our altitude exactly right. Or for that matter, we haven't even used a ruler here to connect these vertices to make the triangle. So the graph isn't 100% accurate. So it wouldn't be 100% accurate to read what point G is directly from the graph. It's better if we can calculate that point mathematically. So we know that we need to find the point of intersection of the altitude, which is line segment EG, and line segment DF. So we want the point of intersection between those two things. And in order to find the point of intersection, we first need to know the equations of both of those lines. Well, we have the equation of the altitude. So the equation of EG, we just found in the previous question, is y equals negative 3x plus 10. What we don't know is the equation of DF. So we need to find that. Okay, so to find the equation of DF, we need to know the slope and the y-intercept. So for DF, we know that the slope is 1 over 3. We had already calculated that in the previous question as well. And it goes through both points D and F. So we can use either point. Let's say we use point D, and the coordinates of D are negative 3, negative 1. Okay, so we can determine this equation. We have the equation is in the form y equals 1/3 x plus b. And we can substitute this point negative 3, negative 1 for x and y. So negative 1 is equal to 1/3 times negative 3 plus b. So negative 1 is equal to negative 1 plus b. And so b is equal to 0. So we now know the equation of df is y equals 1/3 x. So we now have both of these equations. And if we want to find what point G is, we have to find the point of intersection of EG and DF. So using these two equations, we can use substitution or elimination, if you know that method, to solve for the point of intersection here. So again, my two equations are y equals negative 3x plus 10 and y equals 1/3 x. So first of all, I can take the expression for y from the second equation and substitute it into the first equation to get 1/3 x is equal to negative 3x plus 10. Often what we do when there's fractions involved in the equation is we multiply every term in the equation or multiply both sides of the equation by the lowest common denominator. In this case, the lowest common denominator would be 3. Multiplying the left side by 3 gives me x. Multiplying the right side by 3 gives me negative 9x plus 30. Okay, adding 9x to both sides gives me 10x equals 30. And then dividing both sides by 3 dividing both sides by 10 gives me x equals 3. So I know that the x coordinate of the point of intersection is 3. To find the y coordinate of the point of intersection, I substitute this x equals 3 into one of these equations. So let's substitute it into equation 2. And so I get y is equal to 1/3 times 3. And so y is equal to 1. So the point of intersection of those two lines is, and I'm going to call it point G because that's what we had labeled it on the graph. So point G is 3, 1. Now that's still not the end of the question. So let's go back to our picture for a moment. So we want to determine the length of the altitude from vertex E. So right now we have the coordinates for vertex E and we have the coordinates for vertex G, which is 3, 1. See, we were a little bit off with our picture initially. Now, in order to find the length, now that we have the two coordinates for the endpoints, we can use the length formula. So we want the length from point E, which is 2, 4, to point G, which is 3, 1. So using our length formula, we subtract the x coordinates, so 2 minus 3, and square it. And then we add, And we subtract the y coordinates, 4 minus 1, and square that. So the length is -1 squared plus 3 squared, which is, we've got the square root of 1 plus 9. And that tells us that the length is the square root of 10. That's an exact answer. Or we can get an approximate value by typing that into our calculator to get about 3.16. So there's a fairly lengthy process to solve that question. What you want to focus on with your questions when you're practicing these types of skills for medians, perpendicular bisectors, and altitudes, you want to focus on your problem solving skills. So your ability to think about a larger question and figure out what are the small pieces of this question, of this solution, that I need to break this down into in order to get to my final answer. Because here you can see that we went through the process of finding the equation of EG, then the equation of DF by finding the slope and y-intercept. Then we found the point of intersection of those two lines, and then we finally calculated a length. So you really want to practice your ability to look at a question and determine what is the step-by-step procedure that you need in order to get to a solution here.